Hello guys, welcome back to another video, and this time around we're going to talk about chapter 3 Form 4 KSSM. So before we go on to delve into more about the chapter, I would like to relate this chapter 3 that we're about to enter with chapter 2. So the last part in chapter 2, which is in the last video, we talk about the relative atomic mass, where we try to find relative atomic mass from the percentage of isotope and the mass of isotope itself. So just to make it clear, how does it work? For this formula, for example, if you find a sample, so maybe in an excavation or maybe in a site, so for example, someone do some mining and they find a sample, and in this sample, for example, 75% is chlorine 35 and another 25% is chlorine 37. Okay, so you have two types chlorine in this sample, like basically they are existed together. So now how are we going to find the relative atomic mass from this sample? So we can't just state as 35 as the relative atomic mass, and we can't say that it is 37 because both of them are there together. So how we do it, we use this formula, which is, so 75%, so 75 times by what is the mass of the isotope, 35, plus 25 times by 37 and divided by 100, so that will give you 35.5, which we would say as the relative atomic mass of chlorine. Okay, so this is our knowledge from chapter 2, and now we're going to go to chapter 3. It is a bit similar but different in a way. So for here, relative atomic mass, relative molecular mass, and relative formula mass. So these three do differ in a way, but how to calculate and how we determine the value are basically the same. So what is relative atomic mass? Relative atomic mass is when you already have the mass of an atom, and when there is a word of relative, you are basically comparing. So what are you comparing it to? So the mass of atom, you compare the mass of atom with 1/12, so meaning that 1 part out of the 12 part in a carbon-12 atom. So as we all know, and as you may not know, carbon-12, basically the molecular mass, or we could say the relative atomic mass for carbon-12 is 12. So 1/12 part of it is basically 1 unit. So when we are comparing, for example, we are comparing this mass to 1/12, basically how many parts does it take from carbon-12 is the mass of the atom, which we would say that would be the relative atomic mass, or we call it as RAM. Okay, now we're going to go to relative molecular mass. So relative molecular mass is when you have the mass of the molecule. So you have the mass of the molecule, and you compare, since it is still in a form of relative, right? So, and we compare the mass of the molecule to 1/12 of carbon-12. Okay? And next one is relative formula mass. So formula mass is basically when you are considering an ionic compound. So what is the mass of the ionic compound, and you compare it to 1/12 of carbon-12 again. So let us recap. Relative atomic mass is when you compare the mass of an atom to 1 out of the 12 parts in carbon-12. Relative molecular mass is when you are comparing the mass of molecule to 1 part out of 12 parts of carbon-12. And relative formula mass is when you're comparing the mass of the ionic compound from one part out of 12 part of carbon atom. Okay, so now we're going to go to what is atom, what is molecule, and what is ionic compound as a recap for last chapter, and we will go through one by one. So now we're going to talk about what is atom, what is molecule, and what is ionic compound. So atoms are basically elements. Elements meaning that there's only one. Elements are basically a substance that only have one type of atom. So atoms are basically just either metal or non-metal. So it could be a metal, for example, copper, silver, lithium, aluminium, magnesium, copper, silver, lithium, aluminium, magnesium, potassium, and all sorts. So non-metal could be oxygen, could be hydrogen, could be sulfur, could be nitrogen, could be carbon, and so on. Okay, which atom is just what the atom carbon itself. So now if we're talking about molecule are basically substances that consist of two non-metal atoms being bonded with what? A bond that we call as covalent bond. Therefore, molecule are basically two or more non-metal atoms that are bonded covalently. So what is covalent bonded? We're going to talk more in the next chapters. But what I can see now, instead of giving and receiving electron, covalent bond is when these atoms share, neither giving, neither receiving. They share, they give and take. Okay, what about ionic compound? So ionic compound is when you have two or more combination. So there are combination of metal and non-metal together. So when one or two, usually one, so when one metal atom is bonded with several non-metal, could be one, could be two, could be three non-metal atom, and the bond is an ionic bond, so that is what we call as an ionic compound. An ionic compound, there's tons of it in the world. So there could be it could be sodium chloride, NaCl. They could be potassium hydroxide, so potassium hydroxide. There could be potassium sulfate. There could be magnesium oxide, and all, and the list goes on and on. Okay, so atom, like I said, is just either a metal atom or a non-metal atom. So molecule is when two or more non-metal atoms being covalently bonded, and ionic compound is like two or more atoms, but they must be a combination of metal and non-metal. Well, there is an exception of one ion. So there also one that we consider as an ionic compound, which is ammonium, because ammonium does exist in ammonium is an ion. So ammonium is also considered, for example, ammonium sulfate. So ammonium sulfate is also considered as an ionic compound because there is a static force in between that form the ionic bonding as well. So the list goes on for each and every one of them. Okay, so next we're going to talk about how are we going to use this and how does this make sense together. So now we're going to talk about how to calculate RMM, which is relative molecular mass, and RFM, relative formula mass. As we all know, relative molecular mass is basically the mass of the molecule, and relative formula mass is the mass of the ionic compound. In order to calculate both of these, we need RAM. RAM is a relative atomic mass, which is the mass of an atom, like I said just now. So therefore, for example, if I give you water, so a molecule of water, so what is the RMM for water? So we need to calculate the RAM, which is the relative atomic mass of hydrogen. We need to add with the relative atomic mass of oxygen, and you need to know that the number here, which is number below, the number here does have a part in calculation, which is now how many hydrogen do you have? So H2O, so you have two hydrogens, so 2H and 1O, right? So therefore, what is the RAM for hydrogen? Okay, how to find RAM? Usually in exam, it shall be given to you, but if you were to find it by yourself, it is also situated in the periodic table, which is if you look at each of the boxes, the above number, the number that is above the symbol, is usually the number of atom in the periodic table, which is also equivalent to the number of proton. The number of RAM is usually situated beneath the symbol. So hydrogen is 1 and oxygen is 16. Okay, now how many hydrogen do we have here? We have 2 hydrogens, so 2 times 1 plus 16. Therefore, the relative molecular mass of water is 18. Okay, now what about RFM? So RFM, like I said, also goes through the same process. So, but the difference is RFM is basically you are taking the mass, or you not taking, basically you are trying to calculate the mass of the ionic compound. So how to measure the ionic compounds' mass? So you still need the RAM of each and every atom that is in the ionic compound. So now, for example, it is calcium carbonate. So you need to find, or you need to know the RAM, which is the relative atomic mass of calcium, of carbon, and oxygen. So the relative atomic mass for calcium is 40. The relative atomic mass of carbon is 12. The relative atomic mass for oxygen is basically 16, right? Okay. Now we're gonna calculate. So now, to calculate the RFM is, now how many calcium do you see? You see 1 calcium, so 1 times 40, right? How many carbon do you see? So that's 1, so plus 1 carbon, right? And how many oxygen do you see? There is 3 oxygen. Therefore 40 plus 12 plus 48, that would give you 100. Therefore calcium carbonate, the relative formula mass of calcium carbonate is 100. Okay, so this is how we calculate. And now, since we already know how to differentiate atom, molecule and ionic compound, and we also know how to calculate their relative molecular mass and also the relative formula mass, let us know what is the importance of these two values and how does it become a part of chemistry. So what is the importance of RMM, RFM, and RAM? So what is the importance of knowing the value of relative molecular mass, the relative formula mass, and also the relative atomic mass? So these 3 values are equivalent to what we call as molar mass. So what is molar mass? So molar mass is basically a representation value, in chemistry. So for example, if I say I have 1 dozen cat in the house, so that 1 dozen word, that dozen word actually shows equivalent to 6, sorry, equivalent to 12. Okay, so that is why if I say I have a dozen of cats in the house, so I have 12 cats in the house. So in molecular mass, in this molecular mass, formula mass, and atomic mass, it is equivalent to molar mass, which is by definition the mass of 1 mole of substance. So it could be any substance. It could be any substance that is made up of molecule, any substance that is made up of ionic compound, or maybe the substance is only made up of 1 type of atom, for example copper. So what is the molar mass of copper? So to find the molar mass of copper, we find the relative atomic mass of copper. So how to find the molar mass of water? We find the relative molecular mass of water. How to find the molar mass of sodium chloride? We are going to find the RFM, which is the relative formula mass of sodium chloride, which is going to be equivalent to the molar masses. Okay, so I repeat, the molar mass is basically the mass of 1 mole of substance, and the substance can be atom, molecule, or ionic compound. And the mole here is actually a representation value, or we would say a representation word that holds a value. How does it hold a value? We're going to check it out when we're learning about the mole concept, which is the most important part of chemistry. So now we're going to talk about the mole concept. So like I said, mole is basically the representative value. So it's a representative value, or we could say a representation that we use to hold a certain value, that then we can translate it into mass or volume or even the number of particles itself. So now, if for example I have substance A, I have for example 1 mole of substance A. So if I want to find the mass of A, I would multiply by the molar mass. And like I said, molar mass could be RAM, RMM, or even RFM, depending on what is A. So if A is an atom, so the molar mass is equals to the relative atomic mass. But if A is a molecule, the molar mass is the relative molecular mass. If A is an ionic compound or an ionic compound, well yeah, so the molar mass is the relative formula mass. Okay, so now that is how if I want to find the mass of A. What if I don't know the mole of A, but I did an experiment and I already have the mass of A? So I know that originally I put 5 grams of A powder. So now I know the mass of A. I want to find the mole, so I would divide by the molar mass, which is the same thing, either REM, RMM, or RFM, depending on what is A. Okay, now next, if I have the mole of A again, and I were to find the volume. So if from mole I want to find the volume, it is a bit similar with this. So since mole to mass is molar mass, mole to volume is molar volume. So I would multiply mole with molar volume to find volume. I would divide volume to molar volume to find mole. Okay, now there's a bit of similarities here, right, in the terms of the names and how it call and how it relate. So but there is a bit different in how it is calculated. So now for molar mass, it depends on the RMM or RFM or even RAM of the molecule, which is very, very changeable. If I use copper, it would be different. If I use copper sulfate, it would be different. If I use copper hydroxide, it would be different. Because when I change the substance, the molar mass changes, right? But if I'm talking about molar volume, there are 2 specific molar volume that we are going to use. So molar volume is dependent on the condition, which is dependent on the pressure and the temperature. Okay, so we have 2 main situations that we always use in chemistry. So it's either STP, standard temperature and pressure, and another one is standard room temperature. Okay, what is the difference between STP and standard room temperature? So STP is when the temperature is 1 degree Celsius and the pressure is 1 atm. What about standard room temperature? Standard room temperature is when the temperature is 25 degrees Celsius but the pressure is 1 atm. Okay, so this is how we calculate. And the molar volumes unit is always in decimeter cube per mole, while for the molar mass, the unit is always gram per mole. Okay, so by definition, molar volume is the volume of the substance per mole. Okay, got it? So hopefully you guys understand. Next, we're going to move through the number of particles. Okay, for the last bit, if we were to find the number of particles based on the mole, for example, if A is an atom, so I want to calculate how many atoms are in 1 mole of A. So to find the number of particles, you need to remember this constant. So from mole to number of particles, you times it with Avogadro constant. While if you already have the number of particles, to find the mole, you divide by the Avogadro constant. So what is Avogadro constant? So Avogadro constant is a constant postulated or made by a scientist called Avogadro. And the value is, the Avogadro constant is 6.02 times 10 to the power of 23. So guys who are taking chemistry, this is a very important number that you guys need to remember, and it's not gonna be given, it could be given sometime in the exam, but it's better for you to memorize. So 6.02 times 10 to the power of 23, that is the Avogadro constant. So if I were to say 1 mole of copper, okay, if I have 1 mole of copper, so how many copper atoms are in 1 mole of copper? Therefore, to find the number of copper atoms, I would take the mole and times it or multiply it by the Avogadro constant. So it would be 1 times 6.02 times 10 to the power of 23. With that being said, 1 mole of copper contains 6.02 times 10 to the power of 23 atoms in total. Okay, so next clip, I'm going to teach you how to use this with one example for calculating mass from mole, or mole from mass, and one example from mole to volume and volume to mole. Stay tuned, guys. So now we're going to talk about how to calculate from mass to calculate mole, and from mole to calculate mass. So for example, if I say 5 grams of calcium carbonate is used in an experiment. So if 5 grams of calcium carbonate is used in experiment, calculate the mole. So calculate the mole of calcium carbonate. So we have the mass. So mass is equals to 5 grams. What is the molar mass? So molar mass is basically, we need to find based on the addition of RAM of carbon, of oxygen and calcium. How do I know that? Because calcium carbonate is CaCO3. How do I know this? In the next part of the video, we'll talk more about how do I get the chemical formula. So stay tuned for part 2. So for molar mass is basically the RAM for this, which is calcium, plus carbon and the oxygen. So how are we going to calculate that? It is going to be given in question. So RAM for calcium is 40, RAM for carbon is 12, and RAM for oxygen is 16. So it would be 40. So wait, molar mass would be 40 plus 12 plus 3 times 16. Why? Because calcium carbonate CaCO3, there is 1 calcium, so 140 here. There is 1 carbon, so 112 here. And there is 3 oxygen, so 3 times 16. Okay, so that would give you 100 gram per mole. Okay, so now you already have the mass, you already have the molar mass. How to find mole? So mole of CaCO3, the mole of calcium carbonate would be the mass over molar mass, which would be 5 over 100, which would give you 0.05 mole. Okay, this is how we calculate from mass to mole. Okay, Now stay tuned how we calculate mole to mass. So for example, I have maybe 2.5 gram of aluminium oxide. Okay, aluminium oxide. So I have 2.5 gram of aluminium oxide. 2.5 mole. Then it's better to write 2.5 mole. So of aluminium oxide. So if I have 2.5 mole of aluminium oxide, so aluminium oxide is Al2O3. We'll talk more in the next part. So if I already have the mole, which is 2.5 mole, how should I find the mass? So like I said, to find the mass is equals to mole times molar mass. Alright, now we need to find the molar mass. So the molar mass would be the RAM of aluminium plus the RAM of oxygen. Right? Therefore, if we're talking about the RAM of aluminium is 27 and the RAM for oxygen is 16. Now, how many aluminium is there? So there is 2 aluminium plus 3 oxygen. And that would give you how much? Total of 102 gram per mole. Okay, so now we already have the molar mass and we already have the mole. So how should we find the mass? So, pardon me, I'll have to make way. Okay, so here to find the mass would be the mole, which is 2.5 mole times by 102 gram per mole, and got this mole cancelled, so it is 102 times 2.5. Okay, and that would be the answer in grams. Okay guys, so this is how you calculate, and hopefully you guys understand. So next we're going to talk about how to find volume from mole and how to find mole from volume. Okay, so basically to find volume to mole, like I said, you divide by the molar volume. And if you have mole to volume, you are going to times it by molar volume. Okay, so now it's quite similar to our molar mass and how to calculate mass from mole and stuff. So rather than that, I would just show you how to use both of the molar volume given, which is either STP 22.4 or standard room temperature. So I would just write standard room as short, which is 24 decimeter cube per mole and decimeter cube per mole here. Okay, so now for example, if I have 0.5 mole of hydrogen gas. So if I have 0.5 mole of hydrogen gas, what is the volume? So volume of hydrogen gas, if in STP, would be 0.5 mole times 22.4 over, so decimeter cube over mole. So cancel out, it would be 11.2 decimeter cube, or would be 11200 centimeter cube. Okay, but what about if I want to say what is the volume in standard room temperature? So volume of hydrogen gas in standard room would be 0.5 times 24, which would give you 12 decimeter cube. Hopefully you guys understand how to use this. So we already established that, to recap everything, so we already have established that if you have mole, you want to find the number of particles, you times or you multiply by the Avogadro constant. To go back from the number of particles to mole, you divide by the Avogadro constant. From mole to volume, multiply the molar volume. From volume to mole, you divide by the molar volume. From mole to mass, you multiply by the molar mass. From mass to mole, you divide by the molar mass. So hopefully you enjoyed this class today, or I would say a video, a virtual one. So hopefully you understand. Any comments or anything that you would like to add, do tell me, and stay connected with me. I will also link my Instagram and Facebook. So if you have any question, do ask me, and hopefully it helps. Okay, see you around.